Hello everyone, and welcome to today's Immersive Labs live demo session. Thanks to you all for coming, and it's great to see everyone here. This time we'll be covering our latest labs in malware analysis and reverse engineering, a category that I look after in the platform. I'm going to give you a run through of what the labs look like and some of the sort of insights as to the objectives when creating these sort of labs. Just to quickly introduce myself, as you can see on the slides here, my name is Ben McCarthy. I'm one of the lead cybersecurity engineers here at Immersive Labs, and I sort of look after the malware, reverse engineering, and vulnerability research section of the platform. Before we begin, I'd like to quickly go over some housekeeping. First of all, this session is being recorded, and the recording will be available on our YouTube channel, along with our platform and the website. So if you miss anything or you'd like to rewatch, you're always welcome to do that. As well as this, we'll also be sending the recording link to all those who registered for this session. So again, you can watch back at your leisure. Overall, we've got about 30 minutes in total. So I'd like to make sure there is some time for questions at the end. But please do feel free to email any sort of questions if you're rewatching this on the YouTube channel, for example. Or just get in touch via LinkedIn. I'm happy to answer sort of any questions on this. Remember, this is a live webinar session, and like many live sessions, the demo gods are looking over us. So please be mindful of the fact that my broadband could cut out at any point in time. So please bear with me if that does happen. So onto the what we're talking about today. So just a little bit of background on sort of reverse engineering, exploitation development, and malware analysis. So these are often described as the two sides of the same coin. So, you have your exploitation development, which is generally more on the offensive side, and then you have your malware analysis, which is generally more on your defensive side. So, the sort of jobs that would be interested in the series that we're about to talk about today are reverse engineers, vulnerability researchers, and malware analysts. So what we've been doing so far at Immersive Labs is we've been releasing a lot of series to try and get people that don't really have any sort of technical understanding of maybe assembly language, computer architecture, reverse engineering, and trying to get them into this space. And then from there, we're going to, we'll be releasing stuff on much more advanced exploitation techniques. We're going to go into sort of how the heap is structured and heap overflows in future series, stack overflows, format string vulnerabilities, analyzing source code to check for bugs, these sort of more complex topics. But so far in the series, we have a bunch of labs on computer architecture. So that's an introduction to Windows internals, Linux internals, what a portable executable looks like, an ELF executable. We also have assembly language, so you'll actually be writing assembly for each Windows, Linux, 32-bit and 64-bit, and also then reverse engineering each of the artifacts that you create, because that gives you a kind of good understanding of what to expect in a binary when you've actually written the binary yourself. And you can kind of start matching how compilers and assemblers produce executables. So why do we want these sort of series? Well, exploitation development is incredibly important. We need exploit developers to find security holes in software so that they can then disclose them to the vendors. We obviously always hear about the sort of Patch Tuesday from Microsoft and then Exploit Wednesday. The whole point is that these security researchers are finding these vulnerabilities so they can tell the companies so they can get these fixed. So obviously other people aren't using them for more nefarious means. And also from the other side of the coin, malware analysis, we need to understand, malware is such a big threat to basically every company. Very often we'll hear about ransomware, we'll hear about, large Trojans, and then, command and control centers being like brought down by the law enforcement. So we need to understand how to analyze these particular artifacts that you could find on your network, your corporate network at work, and how to extract important IOCs, but also to understand at a deeper level what these pieces of malware are actually doing. Not just, oh, this is making a call out to this IP address, but what sort of defenses does it have? Is it trying to get is it trying to do sort of anti-disassembly techniques or anti-debugging techniques, for example? All of this stuff is really important. And that kind of brings us on to what our 2 new series is all about. So when doing sort of exploitation development or malware analysis, both you'll have a disassembler and a debugger. And the choice of disassembler and debugger for us, for the Windows platform, is Ghidra and WinDBG. Now, Ghidra was released by the NSA and has quickly become an incredibly important tool in the tool set of reverse engineers. I know I use it basically every day. To be honest with you, I absolutely love it. It does come with a decompiler by default as well, which is obviously, if you look at counterparts to Ghidra, sort of IDA, the decompiler is actually a lot of money, whereas Ghidra is completely free and open source. And they do have a lot of support as well, actually. There's a lot of bug fixes. There's a lot of new things being brought out every day for it. So it's a highly looked after tool. And then on the debugger side, we have WinDBG. Now, I can't really explain enough about how good WinDBG is as a debugger. I would say probably the biggest thing when it comes to using WinDBG is that it doesn't look the prettiest, and we will get onto that. And part of the series is to create a workspace inside WinDBG that actually tells you all the information that you need and makes it look that little bit nicer, because it does have that kind of very old user interface feel. Now, WinDBG have actually released this new tool called WinDBG Preview, which you can use, which is an updated UI. However, after using WinDBG for quite a while now, I've kind of got used to how horribly the user interface looks. So I'm kind of sticking to the old user interface until I have to upgrade to the preview. So I did talk a little bit about the Ghidra series that we were, the Ghidra tool, and we have now released a Ghidra series. So this is all about introducing you to the different aspects of Ghidra and what it has to offer. So some of the labs will be about just getting started, opening up a binary, opening up a project, and showing you kind of how to navigate the tool. Other labs will look into improving decompilation and disassembly. So sometimes Ghidra will actually get it wrong. It will say, right, this it will display the assembly in a certain way when actually that could potentially be incorrect. So we're all about trying to improve the way it decompiles and disassembles. Also, it has a pretty powerful scripting engine, and that's one of the things I'm going to demo today. Actually, is how to use the scripting engine to find artifacts or important pieces of information quite quickly inside binaries. And this can be used, to locate vulnerable functions, for example, such as strucopy, strucompare, looking for the very old school buffer overflows. But you can also use it to, start finding stuff like malloc and looking for ways that you can see that a user controlled buffer might be passed into some of these more vulnerable functions as well. But at a basic level, we're just looking for, in the lab, all of these vulnerable functions, and we'll show you how to do that. And that's something that I will be demoing today on the call. On the video. And then the other thing as well is WinDBG. So in the WinDBG series, it's not WinDBG. There are a few other ways I've heard it being said. This is obviously something that's talked about quite often when teaching WinDBG, WinDBG, WinDBG maybe. But yes, it's WinDBG. And so in this series, it's all about, getting started as with sort of Ghidra, but then we start to look at the different things that you can do with WinDBG. So one of the episodes we have is simply walking the Windows structures. It's really powerful to understand. It's really powerful to use WinDBG to look at all of the different structures that Windows has. So you can look at how a PE file, all of its structures in its headers. You can then look at all the different offsets and start locating data. And these are techniques that malware and shellcode often do, looking at the process environment block, for example. And what we're going to do is we're going to show you how to do that sort of stuff in WinDBG. We also go through sort of debugging malware, looking for Windows APIs, and also one of my favorite episodes actually is the final episode, where you're looking at how shellcode uses kernel data structures to locate system level tokens, and then how to actually grab that system level token and replace it to their running process. And again, I think it's really important to kind of understand the sort of data structures used and why they are so difficult to for Windows, for Microsoft to say, oh no, we can't let you access that because then you can get the system token. As a matter of fact, loads of programs need access to this sort of information because it holds such important pieces of information. So it's two very exciting series, both 5 labs each, and it's well, I'm just going to double check that it actually is 5 labs for Ghidra. Yes, you can see there are 5 labs for Ghidra and 5 labs for WinDBG. So if we just let's quickly go into a sort of demo, just quickly open up both of each series, and we can kind of show you some of the things that you should expect inside of this. So as you can see here, we've got the main dashboard. This is my dashboard. If you haven't seen Immersive Labs before, I'd recommend. We've got loads of videos on how to what sort of content we have out there. You can see here, this is my dashboard, say my name, how many labs I've completed, my points. I'm sure many of you on the call and watching this later will probably have a lot more points than I do. Yeah. And I'm happy for you. So if we go to browse and labs by category, we can, once it's loaded again, we are live demoing here, so that's always going to be fun. And then we go to the category malware and reverse engineering. So this is what I was discussing earlier about the fact that we have computer architecture, assembly language, introduction to reverse engineering. I have done a webinar on these 3 series before. But today we are going to be concentrating on Ghidra and WinDBG. For anyone who's looking and sees Radari 2, I just created a series on that a while ago because it's just quite a fun little sort of CTF style tool. So let's go into Ghidra and have a look at this. So as you can see, we've got 5 episodes, projects and getting started using the 3 heads. So the 3 heads of Ghidra. So that's the disassembler, the decompiler, and the graph view. Then we've got aiding analysis. So that's kind of downloading Microsoft symbols and understanding how they are used inside Ghidra to understand decompilation and disassembly a little bit easier, a little bit better. Then we've got the scripting episode, which I'm going to take you through today. I'm not going to go through the whole lab. I'm kind of just going to zip over it and have a little look at it and talk about the things inside of the lab, because I don't want to ruin it, and I don't want I want people to go and actually do the episode themselves. And then finally, we've got episode 5, improving decompilation. So let's open up Ghidra episode 4 scripting. As you can see, I was the pioneer when I was, when I put it onto the platform. So in this episode, you will learn how to use various aspects of Ghidra to automate finding vulnerable functions using a customized script. Now, Ghidra has an incredibly powerful API, and what's actually really great about the tool as well is that it is very well documented. The API, I would say, is quite nicely documented. People on this call may be thinking, Ben, what are you talking about? The API is pretty horrendously documented. And I'm going to be honest, I've seen a lot worse. There's nothing worse than having a tool released and then there is an active API, but you can't understand really how to use it. So as you can see here, the whole point of this lab is to create a script that looks for the variation of struct copy within this binary. So if we go to the info section, you can see we've got a lot of screenshots to show you where to go in order to start sort of creating your own scripts. So let's go to Ghidra here. I agree to the user agreement. No active project. So, if you haven't seen Ghidra before, this is all stuff that you will learn in the first episode, is how to create a project, how to import binaries into it, what all of these different parts of the process mean. So I always like to drag it over the dragon and then have the dragon kind of pop up and say hi. So as you can see here, it tells you a little bit about how to create a script. Now, yes, we do want to analyze it and analyze it in the default manner. There are a lot of scripts already downloaded and ready to use in Ghidra. A lot of them are really good. A lot of them are used automatically by the analysis when I pressed analyze a second ago, but some of them are not as well. So we can take a lot of those scripts and kind of change them up a little bit, or even improve them if we want to. What I would say is that if you do feel like you are improving some of the scripts, it might be worth even actually going onto the GitHub, creating a pull request for Ghidra and updating the script and saying, this works just a little bit better. It's all about helping out the community, isn't it? So as you can see here, there's many powerful APIs. There is an actual, you can actually visit the Ghidra API, or we can go to help here within the tool and go to Ghidra API help. And you can see it's extracting the Java doc. And you can see here we've got a lot of information on different parts of the Ghidra API. So we can go to package, class, Ghidra script development, for example. And there's a lot, and we can go and search as well. So for example, there's the find first function, which is something that I talk about in the lab. Let's go to find first function. Maybe that didn't quite work because I typed it in incorrectly. Find first, so we can find first address. I'm not 100% sure as to why the find first function is not coming up, and this is the point of the sort of live demo, which is not always great, but that's fine. So one of the first APIs to use is the get function manager, which sets up the interface to start getting function functionality. So if this little green and white play sign you can see up here is how to start displaying the scripts. So you can see here there is a lot of scripts already pre-downloaded here, ready for you to use and mess around with. But what we want to do is we actually want to create a new script. You can see here that we can do it in either Java or Python. Java is a lot more powerful. You get a lot more access to better APIs, but for what we're doing here, we just thought that Python was a much better way of doing it. And let's just go test, for example, test.py. Awesome. So now, we can actually go and create our own Python file. So one of the things that we talk about here is the find first function example. Okay, so right, it's not an actual, that is just me sort of naming the function called find first function. What we actually need to be using is get functions and then iterating through the returned function names from that. So what we can actually do is just copy this here. This example here is finding the str compare. Now, as you will probably find in the lab, it says create a script that looks for the variation of str copy. So there's it's not actually just str copy that is used in the binary. There is a variation of it being used. So the way that we find that out is yeah, we can't do anything while this is open. So let's go back to it. Cool. So if we go to functions here, we can look and we can find, if we type in str, we've got str copy here, we've got str n copy here. So if we go str copy, you can see that that's actually being implemented as underscore str copy. Now the underscore str copy will actually is just a func to the actual str copy, but the underscore str copy is what is implemented actually in the binary, and it will just then link out to this. And then so let's let's have a look. So as you can see here, I've commented the code here to say create a function manager interface, set up the function iterator, iterate through the list of functions to search through, and then compare with the name of the runnable function to search. So when you execute this this bit of code, you'll see the output down here at the bottom. And what you can do is that any of the memory addresses that come up, you can simply double click and it will take you to that location inside the disassembled view and the decompiled view as well, which I think is a really useful thing to have. And then what we want to do after that is, once we've found the function name, so str copy, str compare, what you can actually do is pass a list into this script, so you can have all of them: str copy, str compare. I feel like I've said str copy a lot of times. Other ones like mem copy, mem compare, printf if you're trying to look for sort of format string vulnerabilities, and it will you can pass all of them, and then you can see where they are used and then get their cross references. Now this is some of the most powerful things that tools like IDA Pro, Binary Ninja, Ghidra give us, is this idea of cross referencing. So where something is actually used within the binary. So, as you can see here, this is all cross references, but this is like a manual cross reference. So I can double click this, for example, and you can see str copy is used here. Or if I go back, you can see in function underscore function 3, str copy is also used here. So obviously it's when there's only sort of 3 or 4 different like cross references, it is something that you can do manually, but we've got to remember that malware can get quite large. Generally it's not that big, because obviously you wanted to kind of keep the binary relatively small, but obviously enterprise corporate software that you're looking for exploits in, that can be absolutely huge. So you might have a lot of cross-referencing. So using these scripts to automate this process is a really important skill to have. Like I said, I'm not actually going to go through doing any of this, because I don't want to actually show you how it's done. And the lab is what we describe as a coach lab. which means that the point is that it takes you through and gives you all the information needed to be able to then go and actually complete the lab. So I'm going to kind of give it as a challenge. Go and complete the lab. Come back to me and ask it, and either say, "Oh, that was great, Ben," or "I liked it, but maybe you could do other stuff or whatever." I'm always up for hearing a little bit of feedback on it. Now, let's move over to WinDBG before we talk a little bit about what's coming in the future for malware reverse engineering. So, as I was saying earlier, WinDBG, incredibly powerful debugger, especially when it comes to analyzing Windows internal structures. And this is everything that we're actually doing in this episode, for example. So in episode 3, you take what you learn inside this this lab, and you actually analyze shellcode that goes and performs various checks that you see for different structures that you see in this lab. So let's actually load WinDBG up. And as I was saying before, it's not exactly the prettiest looking tool ever, but that's the way it is. And let's open Notepad plus. Sorry, not Notepad plus, just Notepad. And as you can see here, the first thing it gives us is a little bit of information about where Notepad is loaded, the different DLLs that Notepad uses, but on this machine as well, we also have a bunch of symbols already downloaded. So what we can do is we can do sympath C symbols and then load. And what that does is that loads the symbols for each of the DLLs so that we can just much better analyze each of these Windows structures. So I'd really recommend doing that for every single time you need to look at sort of Windows data structures. And then if we go back to LM to load modules, you can see that now all of the symbols are loaded. So earlier, not many of the symbols are loaded. Now all the symbols are loaded. So as you can see in this lab, there's a lot of information on kind of understanding the different data structures. So for example, we've got the PE header. So what I like to do is I like to give you a little bit, give you an example of that sort of different commands being used, but in slightly different ways, so that you then have to apply it to the practical exercise at hand. So you can see here DT image DOS header and this memory location. So you can see here that this memory location differs to this memory location here. So you need to ensure that you're running LM, for example, to check where Notepad has actually loaded. So if we go to DT underscore image underscore DOS underscore header, and then let's take that at the 0 because I missed it. Might take a little while. It does say busy, and eventually we'll get a little bit of information, and we will actually get the offset of the structure, then the actual structure itself, and then the value of that structure. So 5A4D, if anyone knows what 5A4D in hex is, please comment it, just as like a very fun little simple challenge. But as you can see here, I've also kind of highlighted the important bits that malware or shellcode will generally need to be aware of. So there isn't a sort of way for shellcode to just simply locate data that it wants. It needs to find data structures, use those data structures to potentially find other data structures, and then find the specific information needed in those data structures. So what I wanted to kind of do is to show you in this lab the way that malware might look for import directory stuff. So for example, locations of like if this executable is importing a function from kernel32.dll, it will have that in the import directory. And so this is the kind of process that the shellcode would do to locate that import directory, or well, could do to find the import directory. So as you can see here, we've got plus 3c, which gives you the LFANU, which is the kind of pointer to the new PE header. So as you can see, that is what is explained here. So what we want to do is from there we could actually the exercise actually takes you through going through the data directories and manually seeing the import directory and the export directory, for example. So as you can see here, we've got the image import descriptor, which is one of the structures that's inside the import directory, which tells you, gives you all the information about a pointer to the name of the DLL. So the first DLL that it imports, so that could be user32.dll, that could be GDI32, that could be kernel32, that could be NTDLL, if they don't import very many functions. But then also from this sort of beginning at the PE header, you can also go and find the export directory. Now, one of the things that you may be thinking while looking at this is like, well, notepad.exe is an executable, it's not a DLL, so it doesn't export anything, and you are correct, yes. Yeah. So in the lab, you won't be going through notepad.exe's export directory, because that is actually 0. It doesn't actually have an export directory. It's a size 0. So what we do is we get you to look for kernel32, and then you go through the whole process of looking at the headers for the kernel32 instead, kernel32.dll. And this is what malware will be doing as well. It will either, if it's a DLL itself, it will either if it's malware will then go and look for DLLs, look for their exports, and start passing different functions that way, for example, because they know that kernel32 DLL will export a lot of very important functions, which you'll actually find out in the next episode, debugging malware, where you look for load library A, get proc address, for example. These are two examples of APIs that piece of malware actually looks for. So yeah, I didn't really want to kind of go through in too much sort of technical depth the actual practical, because I kind of want the people viewing this to enjoy and go through their labs themselves. So please do go and visit these labs. They took a while to create, and a lot of research and time have gone into them. Like I said, if you go to browse lab by category, malware and reverse engineering, you can see the beginning, all of the beginning series, and then the 2 latest series, Ghidra and WinDBG. Awesome. So finally, before we sign off the call, we have what's coming up next. So what is on the roadmap? It's actually incredibly exciting. As I was saying before, everything that we do, that we've been doing so far, has been about releasing labs to give you the technical understanding to go and do what we're about to release, and that is vulnerability research. So that is taking exploits like stack overflows, use after free, integer overflows, integer underflows, double freeze, a whole variety of different heap exploitations, format string vulnerabilities, and then even some very fun symlink exploits as well. But also showing you modern mitigations, modern and then modern bypasses for these mitigations by fully updated Windows machines. Now, this is this is going to be an incredibly exciting like series, but all of the stuff that has been created, so for example the WinDBG and the Ghidra, are going to lend heavily into being able to do these series. So you need to have done a lot of those series first to have the technical knowledge to be able to go and do the coming series. So very exciting. Keep an eye out for it. I will definitely be doing a webinar where I'll be going into probably a lot more depth on maybe pick one of the exploits and we can kind of go through it together. You can see how Ghidra and WinDBG are used side by side to analyze different pieces of software, either created by us in-house or real life software that has these sort of vulnerabilities that we can that you can go through inside the lab. So that concludes the webinar today. Thank you very much for listening to me. I hope you found it exciting, and I hope you can go off and actually do these labs now, because yeah, I would absolutely love that. So yeah, once again, my name is Ben McCarthy. This has been Immersive Labs. Thank you, and have a good rest of your day.